Hiya 3 and welcome to another maths lesson. Yesterday we spent time becoming really fluent and confident with our 3 times table, and today we're going to be using that because our learning objective is to multiply by 3. So before we start, let's just do some counting in our 3s to make sure we're really ready. So count along with me. We've got 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. And like I said yesterday, that's something that's really useful to keep practicing counting in your 3s, forwards and backwards. Okay, so we're going to do some multiplication now, and we want to find out how many wheels we have got all together. And each tricycle has got 3 wheels, so we're going to need to count in our 3s, because this one's got 3 wheels, this one's got 3 wheels, as has this one and this one. So we've got 4 tricycles and they've got 3 wheels each. So let's count in 3s. 3, 6, 9, 12. So we've got 12 wheels all together. If I was going to represent that on my number line, I'd count in jumps of 3 4 times, because I've got 4 tricycles. We've got 1, 2, 3, 4, 3, 6, 9, 12. I jumped in my 3s 4 times. So if I was going to write that as a multiplication sentence, we can say that I've got 3 4 times, and we can see it equals 12. Okay, so let's try another one. We've got some dominoes now, and they've all got 3 dots on them. So we've got 3 dots here, 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, and 5 groups of 3. So we can see we've got 3 5 times. So let's count in our 3s to find out the total. 3, 6, 9, 12, 15. So if I was going to represent that on my number line, we would need to do 5 jumps of 3. So we're going to jump in our 3s. 3, 6, 9, that's 3 jumps. 12, 4 jumps, and 15, 5 jumps. So to write that as a multiplication sentence, maybe you could pause me, write down what you think, see if you're right. I'm going to write down that I've got 3 5 times, and I can see that it equals 15. So 3 times 5 equals 15. Okay, let's try another one. I'll tell you what, pause me now, and then try all of this one yourself. So look at the groups of 3 on the clover leaves. What would it look like on a number line, and how would you write it as a number sentence? Pause me and have a go. Okay, so we can see our groups of 3 on our leaves. 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, 5 groups of 3, and 6 groups of 3 this time. So I'm going to count in my 3s to find the total. 3, 6, 9, 12, 15, 18. I'm now going to try and represent that on my number line. So I've got 6 groups of 3. So I need to do 6 jumps of 3 on my number line. So 3, 6, 9, 12, that's 4. 5 groups of 3, 15, and 6 groups of 3 gets me to land on 18. So to write that as a number sentence, see if you were right, we've got 3, and we have 3 6 times, and we can see it equals 18. Okay, so now we're going to try and write the multiplication sentence to match where we landed on our number line. So we've landed on 9. We're trying to make 9, and we're trying to count in multiples of 3. So 1, 2, 3. 3, 6, 9. We needed 3 jumps of 3 to get to 9, because 3 times 3 equals 9. Can you have a go at this one? What would the multiplication sentence be to match this representation? Pause me and write it down. Okay, so hopefully you had 1 times 3 equals 3, because we had one jump of 3 to get to 3. Okay, have a go at this one. You're trying to get to 15 this time. How many jumps of 3 do you need to do to get to 15? And what's the number sentence that matches that? Pause me and have a go. So if I was going to do it, I'd start on 0, 3, 6, 9, 12, 15. And now I'm going to find out how many jumps I needed to do. 1, 2, 3, 4, 5. So I had 3. So I jumped in jumps of 3, and I did 5 jumps to get to 15. So 3 times 5 equals 15. Okay, so moving on now. Eloise wrote this. So she's drawn some triangles. You can see she's drawn 1, 2, 3, 4 triangles. And we know that triangles have got 3 sides. So she says this shows 3 times 4 equals 12, because she's got 3 sides 4 times. 3, 6, 9, 12. I want you to have a go now at drawing a picture like this. So use triangles to show 3 times 7 equals 21. Prove that is true for me by drawing your triangles. Pause me now. Okay, so I need to draw 3 7 times. So there's one triangle. It's quite tricky with the computer mouse. That's 2. Got 3 2 times. 3 times. 4 times. 5 times. 6 times. And 7 times. Let's check it equals 21. 3, 6, 9, 12, 15, 18, 21. So you should have had 7 triangles to represent that equation. Okay, so moving on. There's some representations down here, and I want you to have a think about which of these could represent groups of 3. So let's have a little look. Which of these do represent groups of 3? I can see groups of 3 here. Can you see in my array there are some groups of 3? Does this one represent groups of 3? Look how they have been grouped together. 1, 2, 3, 4, 5. So that's a group of 5. It's a group of 5 3 times. So hopefully that one didn't catch you out. Have a look at this one. Does this one represent groups of 3? Have a look at what coin it is. It's a 5p coin. So it's a group of 5 pennies, and you've got 3 of them. So that doesn't represent groups of 3. Again, it represents groups of 5. Move on to the Numicon. What are you thinking about this one? Does it represent groups of 3? A 3 and a 5. They're not equal groups, are they? So that doesn't represent groups of 3. The next one, does this represent groups of 3? Yeah. So we've got Numicon 3s, and we've got 1, 2, 3, 4, 5 of them. We've got 3 5 times. And if you look at the array at the end, does that represent groups of 3? Take a look. We could group it like this, and you've got groups of 3. Okay. So now we have found which ones do represent groups of 3. I would like you to write a multiplication equation for the picture that does represent a group of 3. So pause me and do that now, and then unpause me when you're ready to hear the answers. This one, groups of 3, and there's 1, 2, 3, 4, 5 groups of 3. So 3 times 5 equals 15. I've got 3 5 times. This one does not represent groups of 3, so I'm not going to write an equation. Nor does this one. Nor does this one. That leaves us this one. And again, we've got 3 times 1, 2, 3, 4, 5 equals 15. And the same as the last one, we've got 3, 1, 2, 3, 4, 5, 5 times. So that will also be 3 times 5 equals 15. Okay, moving on. Have a little look at the two sets of arrays. This side asks us to circle the groups of 3. So have a look. Which way do I need to circle my groups if I'm circling the groups of 3? I'm going to do it this way round because then I've got 3 in each group. So I've circled my groups of 3. How many groups are there? 1, 2, 3, 4, 5, 6, 7. There are 7 groups of 3. On this side, it asks me to circle the 3 equal groups. So where are the 3 equal groups? They go the other way. It's 1 group, 2 groups, and 3 groups. And how many are in those groups? There are 3 groups of 1, 2, 3, 4, 5, 6, 7. 3 groups of 7. So our number sentence is in the middle. For this side, we've got 3 7 times, which equals 21. And for this side, we've actually got 7 3 times, which also equals 21. Because we know multiplication is commutative. It can be done in any order, and the answer still stays the same. So the next thing I would like us to think about is using our greater than, less than, or equal symbols to make these equations correct. So you need to look at the equation on both sides. On this side, we've got 3 times 2. We know that 3 times 2 is 6. And on this side, we've got 3 times 5. 3, 5 times. I count in my 3's 5 times. 3, 6, 9, 12. I get to 15. So now we can think about which side is greater than the other side. We know that 15 is greater than 6, so we use that symbol. Pause me and have a go at the other two. Okay, so I can see 4 times 3. 4 times 3. I need to count in my 4's. 4, 8, 12. I counted in my 4's 3 times and I got to 12. And on this side, 3 times 4. I need to count in my 3's 4 times. 3, 6, 9, 12. That's an example of how multiplication is commutative because they equal the same. And finally, 3 times 9. 3, 9 times. You can use your fingers, you can count in your 3's 9 times. I know it's 27. And 8 times 3. Now you learnt your 8 times table last week. But if you're not that confident with your 8 times table, what could you count in instead? You could count in your 3's 8 times. And I know 8 times 3 or 3 times 8 is 24. So I can see that 27 is greater than 24. Okay, finally, I want to know which representations you can match and why you can match them up. So I'm going to give you a little bit of time thinking about which representations could be matched together. Okay, so I can see 3 times 4. 3, 4 times. And I can also see 3, 4 times down here. So this one and this one could go together. Could anything else go with them? What is 3 times 4 or 4 times 3? It's 12, so that could link with this representation as well. Let's take a look at this one. We just group our 3's. We've got 3, 3 times. Can you see anywhere else where we've got 3 times so we can match that representation? With the dominoes, I can see 1, 2, 3 groups of 3. So the array and the dominoes can match together. Do they match anything else? The number line. 3, 3 times. We've jumped in our 3's 3 times. So that also belongs with that group. Now, it looks like we might have an odd one out. I can see 1 3 down here. Your challenge now is to draw 3 more representations. So this is no longer the odd one out. What could you draw to show me 3 one time? Have a go in your books now, and then when you've done that, you can get on and carry on with your IP. Enjoy!